let's talk about the different types of problems when we're dealing with percents. And we're going to start with one that's called percent of change, and here's the key word, percent of change. However, let me give you a couple other key phrases. It might say percent of increase, or it might say percent of decrease. So we might get in the habit of doing a lot of other different types of problems like we're going to do later, but then don't lose sight of the fact that sometimes it asks for a percent of change, and in that case we're going to figure out basically how much it changed. And not just how much it changed, but what percent it changed. So here's the formula. It's going to be the change divided by the original, and that's pretty much it. I mean, we multiply by 100 to move the decimal over two places. We'll have to subtract to find the change, but let's do this. So what was the percentage change in the price for a gallon of gas in this 25-year span from 1990 to 2015? Basically, gas went up from $1.15 to $2.45. So $2.45 minus $1.15 is going to give me $1.30, in case you care. And the original price, based on 1990, as the standard, is $1.15. And so we are going to just do this. Now, if you type it on your calculator at one time, you'll have that. And if you're a little bit ahead of me, you'll realize that we have more than 100%. And it is okay to have more than 100%. It really is. I know people probably told you it wasn't and it was illegal. And it depends on the circumstance. But in this case, it's perfectly okay to have more than 100%. Particularly when you're dealing with percent of change. But when someone says you got to give 110%, well, you can't. You only have 100% to give. You can either give all or something less than that, but you can't give more than that. But in a circumstance like this, it has increased, there we go, a 1.13. And that 1.13 is fantastic, but it's not quite our answer, so 1.13. So essentially, this is 1.13 times what it was, and no, I lied. That's not the right way of interpreting that. It's increased by 113%. So it added itself and then 13% more. That's the way I should have worded it. And I'm not going to go through that for the next couple. We get down to some of the word problems, though, and that's where things get a little bit wacky. So we get to number 5, for example. What is 23% of 50? Or number 7, 8 out of 12 is what percent? And we're going to use this as a standard for how we do a lot of the other problems that we may not be able to kind of wrap our minds around what to do. So what is 23% of 50? Well, I don't know. So I'm going to use a variable like n. N is, well, it's what? I don't know what it is. Is means equals, and 23%, let's move the decimal over two places, so it's 0.23. Oops, what's the wrong thing? And I don't have my white out here. It's okay. We'll make it work. 0.23 times 50. And now we just solve it, and there's not really much solving to do. We can just type that straight in the calculator. So 0.23 times 50, and we get 11.5. So let's just put this in context. 23% of 50 is 11.5. So you have $50 and somebody's like, hey, can I have 23% of that? Not that they'd say it. You'd give them $11.50. Or maybe you wouldn't, but that's how much it is. So that's basically taking a word and turning it into an equation. So let's do the same thing with 7. By the way, number 6 is just like number 5. 8 out of. Now, if you see the phrase 8 out of, the phrase out of, it means divide. So 8 out of 12 is means equals. What percent? Now, I don't know, but we'll find out. So we do 8 divided by 12. 8 divided by 12 is the same as 2/3, and in case you're wondering, that is 0.6 repeating, and that's n. And so what I'm going to do is write just a bunch of 6's, and then we'll go from there. Now you might be like, oh, we're done. Well, we're not done, and here's the reason we're not. It asks what percent it is, so my answer better say such and such percent. So if I have 0.6666, don't get carried away and be like, oh my gosh, he has 3 6's in a row. It's okay. So that's sort of my answer, but it's sort of not. Let's move the decimal over a couple places. And when I do, I have 66.6 repeating percent. I mean, it keeps on going. And so we have 66.6 repeating. By the way, if I repeat a 6, it's the same as having, and we've been through this, 6 over 9. 6 over 9 is the same as 2/3. You could say 66 and 2/3%. Either one, same thing. Okay, when you get to number 9, you have to solve just a little bit more. It's going to get a little bit trickier. So What percent, I don't know, so we'll call that N. Of means times, 70 is 80, is means equals. And so we'll just solve this like we'd solve any other equation. N times 70 is 80, so we'll divide by 70. And we divide those out. And we have 80 divided by 70. And 80 divided by 70 is going to give me a crazy number. And I'm going to round it off a little bit. So N equals 1.1428, blah, 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 blah. I'm going to leave it at that. That's perfectly fine. But be careful, that's actually not the final answer because it said what percent. So I need to change my answer to a percent. So I'm going to call it 114%. Okay? So that idea is going to be used, the equation idea is going to be used on some of them that are a little wordy. And you don't have to do it this way, but this is the best way I know to explain some of them. So 11. When a grizzly bear hibernates, its heartbeat is 10 beats per minute, which is 20% of its normal value. What is the normal rate of the heartbeat of a grizzly bear? So let's think about it logically. If a grizzly bear is resting, first of all, don't wake it up. Second of all, this is much lower than it should be, and it's 20% of its normal value. You might be able to do this in your head. That's fine if you can. Actually, it's really clever if you can. But if you can't, that's okay. Now, we're going to solve a lot of the other ones using a proportion, but this one we're not. We're going to do it slightly different. And here's what we're going to do. We're going to write a sentence. This is just the way it processes in my head. Maybe this is how it works for you. Maybe not. I don't know. But we're going to make a sentence out of this. So here's what it's asking. What's its normal value? And here's what I do know. 10 is 20% of what? And that's what it's really asking. 10 beats per minute is 20% of what? I don't know what it is, but I'm about to find out. So let's do this. 10 equals 0.20 times something, and I'll divide. It'll divide by 0.2. And we can cancel those out, and we have N equals, 10 divided by 0.2 is 50, in case you always wondered that. That's what that is. So we have 50, and I'm going to kind of write it as a sentence, so, well, not as a sentence, but I'll write what it is. It's not just 50, it's 50 beats per minute. So a bear that is not hibernating has about 50 heartbeats per minute. Okay, let's flip this over. We're going to hit a few other random problems. Number 12 is a lot like some of the other ones we've done. And I'm going to do this one two ways. You don't have to do it both ways, but it just sort of helps us understand it. In our solar system, 6 out of 8 planets have moons. Okay, 6 out of 8, what percent? Well, is what percent? I don't know, but I'm going to take that sentence and make an equation out of it. 6 divided by 8 is something, and I can figure it out, and when I'm done, I'll turn it into a percent. So that's the first way, and here's the second way, and I'm going to kind of divide it up here. I'll do part over the whole equals percent over 100, and it's asking for the percent. So basically 6/8 is what as a percent? And I'll let you finish that. So other random question. Which 2 planets do not have moons? Well, obviously we have one. And the large gas planets do. So Jupiter does. Jupiter has over 60, and they're still discovering more. Saturn has 50-some, I think 40, 50-some. Uranus, and that's the way it's pronounced for real. Uranus has several. Neptune has several. Pluto, not a planet anymore. It's a dwarf planet, but it has several. And actually, Mars does. Mars has 2 very small moons. This has nothing to do with what we're talking about. But anyway, not percentage, but let's go with it. Mars has 2 moons. Phobos and Deimos is what they're called, and they're very, very small. They're not like ours at all. They're kind of irregular. So the 2 that don't have moons are Mercury and Venus. There you go. Now you know. I'm not going to do 13. I'm going to set up 14 and then just hit a couple other ones, and that'll be it. So Luke and Matthew. They wrote books of the Bible now. Luke and Matthew ran a lemonade stand on Saturday. They agreed that Matthew would get 60% of the profit because lemonade stand was his idea. I left out a word. I should say the lemonade stand was his idea. They made a profit of $25. How much money will Matthew get, and how much money will Luke get? So let's answer the Matthew question first. Let's find out how much Matthew's going to get. So you can turn it into a sentence if you want to. you can say, what is 60% of 25? You could. And I'm going to write that, but you don't have to do it that way. What is 60% of 25? And this is the way I used to teach it, where we turn everything into a sentence. I'm not going to do it that way now. Go for it if you want to. But I'm going to do it this way. Instead, I'm going to come over here and I'm going to say, well, 60% is 60 out of 100. And Matthew's going to get something. I don't know what he's going to get, but he's going to get a part out of the whole, and the whole is 25. So we'll do it that way. So Matthew is going to get something out of 25, that's the whole, and it's percent out of 100. So we've had this equation before. I'm going to write it in red just to make it stand out. So percent over 100 equals part over the whole, and sometimes that's kind of hard to wrap our minds around. So there you go. We won't always do that. Let's set up 16, and then I'm going to skip a bit and do some of the more difficult problems towards the bottom. 15, 16. Let's do 16. A sweater that you want is 30% off. If it's normally 40, how much will you save? How much will it cost? Okay, so let's do this idea. Let's do percent over 100 is equal to part out of the whole. Well, the whole price is $40. And that is going to be what it is. You know how to solve that, so I'm not going to go any further with that. But I'm going to go ahead and tell you that X is not what you spend on the sweater. So think about this. It's 30% off. You will not pay 30% of the price. You will pay 70% of it. So whenever you cross multiply and you find X, you're answering this question right here. Then if you want to know how much it will cost, you take that answer and you subtract it from 40. And that's going to tell you how much you had to pay. Can I tell you a different way though? I'm going to do this a little bit differently. If this is what I don't pay, this is what I don't pay. This is the part of it, like this is how much of it that I'm not going to pay for. This is the actual price I pay, and it's going to be set up like this. If I don't pay 30%, I do pay 70%. And this will answer the second question. X means something different in this case. X is the amount that I will pay. So these are two different ideas here. However, again, once you have one of them, you can easily find the other. If this is $5, it's not. But if this was $5, then all I have to do is subtract 5 from 40, and then that'll tell me how much I do have to pay. Okay, so I'm going to slide up a little bit here to number 18. I'm going to do 18 and 19, and then just kind of give a couple pointers on some of the other ones. So here's 18. Sales tax in Guilford County, however, that kind of ties into the last one, is 6.75%. An item costs $44 before tax. What's the total amount you're going to pay if you're going to purchase the item? So here's what we're going to do. We are going to pay that much in tax. So 6.75 over 100 equals something out of, well, $44. Okay, so we're going to do our little magic here. We're going to cross multiply, and I am going to go through the process because I need to keep going. So 100x equals 6.75 times 44. And I have 297. I divide by 100. This one's pretty obvious. We'll just move the decimal 2 places. And x is 2.97. So x is 2.97. That's fantastic. I'm happy. Here's the deal. That doesn't answer the question. What's the total amount that I'll pay to purchase this item? Well, I'm going to pay $44 to purchase this item. And I'm going to pay $297 in tax. So this is the cost of the item. And this is the tax. And so the total is going to be what I get when I add those together, which is $46.97. So I'm going to take an idea here and I'm going to develop it in this next problem because this next one's going to get a little crazy. I just paid the price and then the tax. Okay? Price plus tax. So let's move up just a little bit here. I paid $55.51 for some items in Guilford County. There's your tax rate. How much money did these items cost pre-tax? So basically, I want to know what this is. Now it's not 44, it's something else. So let's develop an idea. Bear with me for a second. I am paying the price. I'm paying for 100% of that price. And I'm also paying the tax, which is 6.75%. So I'm paying 106.75% of the price. I'm paying the whole price and the sales tax. This is how much I'm paying. This is when it's okay to have more than 100%. How much did these items cost pre-tax? I don't know. It's going to be, this is a little weird, but it's going to be part over the whole is percent over 100. So here's the percent over 100. That's bigger, but that's okay. This is an improper fraction. And then the part over the whole. In this case, the part is bigger than the whole. So those words don't make sense here, but I paid this much. I paid this percent out of 100, and I paid this much money when it only cost, well, I don't know. I don't know what it cost. So we'll set it up that way. And the next problem is very similar to that. I'm not going to finish that one. Let me just keep going a little bit. I'm going to just stop that problem right here. And I'm going to slide up and hit just a couple of the bottom ones. And I'm doing this because in this worksheet, I shift from problem to problem, different types of problems. So 21. A baseball player was at bat 340 times and made 111 hits. What percent were hits? Whoa, what's that even asking? This is not sales tax. This is not anything crazy. This is one of those that's part over the whole is equal to the percent, I don't know what it is, out of 100. So again, the types of problems are different. They're shifting from problem to problem. It's not consistently the same type of thing, so you'll need to know how to interpret it. Okay, number 22. Number of seagulls on the beach has decreased from that to that in the past 5 years. By the way, there's a way they can count those kinds of things without like, let's count seagulls. It's kind of clever the way they do it. Anyway, that's a different video altogether. What's the percent of decrease? Whoa, key phrase, percent of decrease. What's that? That's not this. I want to know how it changed. I want to know how it changed. So we're back to this idea. So make sure you're reading the problems carefully.